I'm Isaac, and today I'm going to be talking about black holes and dark matter. Let's jump right in. So, in our solar system, some things make sense, such as planets further from the sun should move slower. This is thanks to Kepler's third law, which, long story short, says if you're far away from a star, you're going to move slow. But they don't. Why? Because there's extra mass we can't see holding them in. That's dark matter, the galaxy's invisible glue and the duct tape of the cosmos. Now let's smash two galaxies together, because we can. When that happens, normal matter like stars and gas collide and get all tangled up. But when scientists measure the gravitational effects, guess what? The mass wasn't where the visible stuff was. It had moved on like a ghost. That invisible mass, again, dark matter, just ignoring the rest. And what is dark matter made of? Nobody knows for sure, but there are definitely some good theories. One of them is WIMPs, or Weakly Interacting Massive Particles. Funny name though. They've got a lot of mass, but barely interact with normal matter. Another good theory is axions. These are teeny tiny particles. They're like 1/10 trillionth the mass of an electron. But under strong magnetic fields, they turn to photons, little bursts of light. So we're trying to catch them, like rare Pokemon, but instead of Pokeballs, we got billion-dollar detectors underground. Now let's talk about black holes. They're not theoretical anymore. We've seen their effects. They bend light. They have glowing rings of dust and gas all around them. And when two of them merge, they send out gravitational waves, literal ripples in space-time. We've detected these waves on Earth. A black hole is so dense its gravity doesn't let light in or out. Einstein's theory of general relativity predicts them. And long before that, in 1784, John Michael said a massive star might trap light with its gravity. No light, no visibility, but the gravity still totally. Once formed, a black hole only has three observable features: mass, electric charge, and spin. Here's an extra fun fact. Spaghettification is a real word. And yes, if you fall into a black hole, you won't just die, you'll be spaghettified. Instead, spaghettification is where the gravity is so intense that it stretches you like cosmic pasta. Your feet fall faster than your head if you're falling feet first. Congratulations, you're now a human noodle. Well, if you're spaghettified, which only happens when you drop into a black hole. Me, personally, I think that's really cool. Another fun fact is that if you want a star to become a black hole, first of all, it needs to implode. It runs out of fuel, so it compacts in on itself. But also, the star would have to be 8 times the mass of our sun. That is huge. So, in conclusion, while you'll not be able to see dark matter or black holes, there there are definitely some ways to detect them, because their effects are detectable. As I said before, their math and physics check out, and their gravitational effect is unmistakable.